Hello and welcome. Today I'm going to talk about the astable multi-vibrator, which is, as its name implies, not stable. Well, how does this thing work? When you apply power to both of the transistors, they're both going to conduct, of course, but because they're component variations, one is going to conduct more than the other. So for the sake of illustration, we're going to assume that Q1, which is this NPN transistor on the left-hand side, conducts more than Q2, which is the NPN transistor on the right-hand side. Well, when this happens, it's going to cause a less positive voltage at the collector of Q1. This negative going voltage is going to be coupled through C1 to the base of Q2, and the forward bias to Q2 is going to be decreased and it's going to shut off. Now Q2 is going to be held off by C1 until C1 begins to charge through the supply voltage through R3. When the charge across C1 is high enough, Q2 is going to turn on. Of course, the LED of Q2 is also going to turn on. Now there's going to be a less positive voltage at the collector of Q2. Now this negative going voltage is going to be coupled through C2 to the base of Q1, and the forward bias to Q1 is going to be decreased and Q1 is going to shut off. Now you can change your frequency, and also you can change your duty cycle, which basically is the on and off relationship within a single period, by changing either here C1, C2, R2, or R3. I'll show that in a second on a breadboard. Now I've got everything hooked up. You can see the LEDs blinking at the moment for C1, which is this here, and C2 I'm using 4.7 microfarad capacitors. I'm going to go ahead and swap these out now with some smaller ones, and we'll see what happens. Before I forget, I got my oscilloscope hooked up to both channels are hooked up to the collectors of each of the transistors. That's basically the collectors of the outputs. I'm going to go ahead and show you. I think there you can see it basically going back and forth. So now I decrease the value of both of the C1 and C2 capacitors from 4.7 microfarads to 0.1 microfarads, and this is what happened. As you can see, there's been an increase in the frequency. Now I'll go ahead and hook up an even smaller capacitor, or even smaller capacitors. Now I replaced the 0.1 microfarad capacitors with 0.01 microfarad capacitors, and this is what happened to the frequency. Let's take a look at the oscilloscope. As you can see, the frequency increased. So now I have the 4.7 microfarad capacitors back in, and the resistors, which is R2 and R3, I think they're 47K. I'm going to go ahead and replace those with 470K resistors, and we'll see what happens to the blinking frequency. We're just using the LEDs for illustration purposes, that's all. As you can see, the frequency has now become slower. What you can do is just experiment around, basically.